Good afternoon, everyone, and thank you for being here today. We are the Ultrasonic Windshield Cleaner team. I'm Sushita Sharma, majoring in computer engineering. Myself, along with John Newman, who is also a computer engineering major, we're responsible for programming a microcontroller and determining the source of power for our device. Our electrical engineering teammates, Angela Shop, Jay Fearing, and Moazin Shop, were tasked with designing and implementing circuits that basically met our project requirements. The goal of our project is to basically design a portable cleaning device that would attach to the inside of the car's windshield, like the GPS, and use ultrasonic waves to vibrate the windshield in order to repel light debris or rain. Our system design involves using a driver circuit and an ultrasonic transducer to produce those vibrations. Just to give you a quick background, a transducer is basically a device that converts one form of energy into another. An ultrasonic transducer converts high-frequency AC voltage into high-frequency mechanical vibrations. Different designs exist for ultrasonic transducers, but the one we chose to go with is a piezoelectric crystal slab design, just because of its wider availability and cheaper production cost, as well as high power efficiency, which is a major aspect of our design. We also used an MSP 430 launch pad for a microcontroller because of its cheaper cost and ease of use. Last semester, we were able to program the launch pad to produce the vibrations or the frequency we needed, which was 40 kilohertz. For test purposes, we used a piece of plexiglass, but realized the power was not enough to vibrate it. So this semester, we focused on designing and testing various amplifier circuits. Some of the circuits we designed were involved using operational amplifiers, MOSFETs, and audio amplifiers. We couldn't find an operational amplifier that met our project requirements, and there were not enough resources or time available to build one on our own. One of the MOSFET designs we experimented included push-pull MOSFET, but it only amplified current and not the voltage, which is what our system needs. And the same was the issue with audio amplifiers. It didn't output enough voltage needed to drive the transducer. So after further research, we found a design that involved using an NMOS. The circuit we designed was basically a voltage multiplier. It was an overdamped condition, meaning that the output voltage was significantly higher than the input voltage, but the current draw was pretty low. However, the transducer was still able to move light, dirt, and water on a piece of glass at 40 kilohertz by reducing the friction coefficient. So at this point in our project, we have an amplifier circuit containing an NMOS that moves debris and water on the surface of the glass. We have come to a conclusion that in order for our design to work in a car, we would have to implement a transformer that operates at 40 kilohertz. We did experiment on a transformer, but it wouldn't operate at more than 60 hertz. Or a DC to DC converter to amplify the signal, step up the voltage and power, which for our transducer specifications is about 120 volts and 50 watts for power. So that concludes our presentation, and stop by our booth and check out the demo.
Any questions?
I'm curious where the idea came from that ultrasonic
While we were looking at project ideas, we realized that our company McLaren is doing something like that in their cars, but it's going to be integrated in their cars. So we decided to make a portable device that would be more convenient.
So how did you decide on 40 kilohertz?
I think we tested various frequencies.
Most ultrasonic cleaning technologies usually operate at 40 kilohertz, and so that's why we make, and that's where most of the transducers, ultrasonic cleaning transducers you buy, their resonant frequency is specified for 40 kilohertz.
So where is ultrasonic cleaning used?
Jewelry, you can clean jewelry with it. You can clean retainers.
Yeah, they use it in dentistry mostly.
But that's for liquids, right? When we actually put something in liquid?
Yes.
Quick question, why is it a square wave instead of like the equals?
Okay, you need a square wave because we're using the square wave to power to turn on and off our MOSFET. And if you use a sine wave, it's gonna get up and it's gonna be on for a little bit at the top, but we want it to be just a strict on or off.
What kind of power requirement you're mentioning that the off-the-shelf components doesn't get you the power?
Right. We experimented with various circuits, and I think the maximum power we got was about 18 watts, and our transducer to be able to fully function requires about 50 watts, 50 to 60 watts.
So, my understanding is that you demonstrated this on plexiglass?
We actually tested it on an actual piece of glass with light, dirt, and water on top of it. So in order to be able to vibrate an entire windshield, we really have to use a very powerful circuit. So right now, it's basically just an actual piece of glass.
But just plain glass, it was
Correct.
laminated with fracture-proof kinds of glass.
Right.
So in your vision, do you vibrate the entire windshield or is random windshield?
With our research, I think at this point, we're only looking at a section of the windshield.
We're using a sheet of glass in our demo. Just like a small sheet of basic glass that you can pick up at any hardware store.
I understand that, but you have to move the entire piece of glass up and down.
Well, you won't see, since the frequency is so, you won't actually see the glass move up and down.
Right, but do you see the waves on the glass?
Yes, we can see
Yes.
some standing waves. Actually, that's what we did today.
What's the reason you wouldn't just go get a jewelry cleaner and use that power supply?
Use a what?
The jewelry cleaner, and usually you can get tens of watts, or maybe 100 watts supply from those cleaners, off-the-shelf cleaners.
Well, at least some of the ones I saw were already into they're actually, you don't have access to the transducer. Now, we did consider buying an ultrasonic driver circuit. The thing is that it was probably going to go over our budget.